Good afternoon everyone. Welcome to Unacademy Gate MEXE PI channel. This is Umamaheshwar Rao. Unacademy learners excel in Gate 2024. 6 rankers secured AIR 1 and 11 plus learners secured rank under top 3. 23 plus learners secured under rank top 10. Unacademy is presenting early bird offer. Early bird offer is back. Flat 50%. Flat 50%. Prices are rising soon by 20%. Offer is extended on popular demand. Unacademy is conducting a Gate 2024 Rankers Recognition Program. You scan this QR code and register now. Unacademy is announcing Amit batch for Gate ESC PSUs 2025 in Mechanical Engineering. Batch commences from March 23rd. Unacademy is announcing Sangram batch for Gate ESC PSUs 2026. Batch commences from March 23rd. Unacademy is announcing Amit batch for Gate PSUs 2025 in Data Science and Artificial Intelligence. Batch commences from March 23rd. Unacademy is announcing Sangram batch for Gate PSUs 2026 in Data Science and Artificial Intelligence. Batch commences from March 23rd. List of books home delivered within 15 days for iconic subscriptions only. Nothing can stop you chasing for your GATE and ESC mechanical and chemical dream. Get started with no cost EMI and 0% interest on the loan. Approval in 2 hours, minimal paperwork and flexible tenures. Crack GATE with Unacademy subscription. Now flat 50% is going on. Now, yesterday I have explained you one-dimensional wave equation. Today I would like to discuss problems related to one-dimensional heat equation. This is also known as diffusion equation. The standard form of heat equation is del U by del T equal to A square into del square by del X square the boundary conditions are U of 0 comma T equal to 0, U of L comma T equal to 0 for any time T, whether X is 0, U is 0, when X is L, U is 0. Now, the initial condition is U of X comma 0 is function of X. Now, by applying the boundary conditions one comma two in the solution of heat equation we get u of x comma t is sigma n equal to 1 to infinite bn sin n pi x by l e power minus n square pi square a square by l square into t. U of x comma t is sigma bn sin n pi x by l e power minus n square pi square a square by l square t, called it equation 2. Now whatever initial condition we have, third condition, that condition you have to implement in equation 2. Okay, now observe the problem I am going to discuss. Observe here, consider the diffusion equation del u by del t equal to del square u by del x square. U of x comma 0 is 0 and u of pi comma t is also 0. Then u of x comma 0 is sin x, then pi by 2 comma 1 is. Now first del u by del t is del square u by del x square, called it equation 1. From equation 1 you can write a square equal to 1. Next, u of 0 comma t is 0, u of pi comma t is 0. From these two boundary conditions we can understand that the value of L is pi. Now by applying the above boundary conditions, in the solution of equation 1, in the solution of equation 1 we get u of x comma t is sigma n equal to 1 to infinite bn sin n pi x by l e power minus n square pi square a square by l square into t, called it equation 2. In equation 2 you have to substitute a square equal to 1 and l equal to pi. Then this equation becomes u of x comma t equal to sigma n equal to 1 to infinite bn sin n pi x by pi, so nx e power minus n square pi square a square. Pi square is l square and pi square will be cancelled because l value pi na, so pi square cancel, a square value 1, so minus n square t, called it equation 3. Now u of x comma 0 is n equal to 1 to infinite Bn sin nx, called it equation 4. Given that u of x comma 0 is sin x, called it equation 5. From 4 and 5, sin x equal to n equal to 1 to infinite Bn sin nx. Now LHS is sin x, RHS B1 sin 1x plus B2 sin 2x, B3 sin 3x, and so on. So by comparing LHS with RHS, we can understand that B1 equal to 1, B2, B3, B4, and so on equal to 0. Now substituting the values of Bn in equation 3, we get u of x comma t is equal to B1, B1 means 1, sin 1x means sin x, 1 sin 1x into e power minus n square t, n value 1, so e power minus t, called it equation 6. In equation 6, by substituting x equal to pi by 2 and t equal to 1, we can get the value of u of pi by 2 comma 1. Now u of pi by 2 comma 1 is sin pi by 2 into e power minus 1. Sin pi by 2 is 1, 1 into e power minus 1, that is 1 by e. So u of pi by 2 comma 1 is 1 by e. Finally the answer is 1 by e. Understood? Observe next problem. Del u by del t equal to del square u by del x square. 0 less than x less than 1, t greater than 0. U of x comma 0 is 1 plus x plus sin pi x into cos pi x. U of 0 comma t is 1. U of 1 comma t is 2. Now observe. If you look at the boundary conditions, we can understand that you have two types of solutions. One is auxiliary solution, another one is auxiliary solution. By using the differential equation del square u by del x square equal to 0, you have to calculate auxiliary solution. Another one is transient solution. Now auxiliary solution plus, that is called stationary solution plus transient solution together gives you general solution. Now observe. Del square u by del x square equal to 0. From this we can write auxiliary equation is m square equal to 0. M equal to 0 comma 0. Therefore, u equal to c1 plus c2 x into e power 0x. That is, I am calling as US. US is c1 plus c2x. Called it 1. Now given that u of 0 comma t is 1, u equal to 1 when x equal to 0, therefore c1 equal to 1. Next one, u of 1 comma t is 2. Two equal to c1 plus c2. From this, 1 plus c2 equal to 2. Therefore c2 equal to 1. Therefore US is stationary solution is 1 plus x. Called it equation 2. Next, we have to calculate ut of x comma 0. I mean transient solution. Observe. Del u by del t is del square u by del x square. From this, we can understand that a square value 1. Now, the solution of heat equation is given by u of x comma t is sigma n equal to 1 to infinite bn sin n pi x by l e power minus n square pi square a square by l square t. In the problem, it is given that the value of L is 1. From the boundary conditions we can understand, because 0 to 1, okay, so 0 to 1, therefore the value of L is 1, a square is 1, L is 1, a square is also 1. From this we can write u of x comma t is sigma n equal to 1 to infinite bn sin n value l value 1 and a square value 1, so sin n pi x e power minus n square pi square a value 1 l value 1 t. Called it equation 3. Called it equation 3. Now u of x comma 0 is sigma n equal to 1 to infinite bn sin n pi x. Called it 4. Given that u of x comma 0 is sin pi x into cos pi x, 1 plus x sin pi x into cos pi x. Observe carefully, sin pi x into cos pi x can be written as two sin pi x into cos pi x by 2. that is nothing but sine 2 pi x by 2, called it equation 5. From 4 and 5, from 4 and 5, we can conclude that sine 2 pi x by 2 equal to b1 sin pi x, b2 sin 2 pi x plus b3 sin 3 pi x and so on. Therefore, b1 is 0, b2 is 1 by 2, b3 is 0, b4 is 0, and so on. Now, u of x comma t is b2 value 1 by 2 sin 2 pi x into e power 2 square. 2 square means 4. 4 pi square t called it equation 6. From equation 6, you have to verify these values. U of 1 by 2 comma 1 by 4 is what? U of 1 by 2 comma 1 by 2 is what? Like that. We have to cross check. Understood? Now u of 1 by 2 comma 1 by 4. First option. One by 2 into sine 2 pi by 2 is sine pi. Sine 2 pi into 1 by 2 sine pi into e power minus 4 pi square into 1 by 4. E power minus pi square. Sine pi is 0. Sine pi is 0. Therefore, this value is 0. Next, second option. U of 1 by 2 comma 1 by 2. First option is incorrect. U of 1 by 2 comma 1 by 2. One by 2 into sine 2 pi by 2, that is sine pi, into e power minus 4 pi square into 1 by 4, that is pi square. Sine pi is 0, therefore 0. Next, third option. U of 1 by 4 comma 3 by 4. 1 by 4 comma 3 by 4. That is 1 by 2 into 1 by 4. 2 pi by 4 is pi by 2. 1 by 2 into sine pi by 2 into e power minus 4 pi square 3 by 4. That is 1 by 2 into sine pi by 2 is 1, e power minus 3 pi square. 1 by 2 into e power minus 3 pi square. 1 by 2 into e power minus 3 pi square. This is the answer. Sir, this 5 by 4 is 1 plus x value. Okay na? Because I told you transient state and stationary solution. From the stationary solution, here you got the answer 1 plus x. Here that solution plus this is transient state solution, this one. Both together you have to calculate. That's why this option is correct. Third option is correct. This is US plus UT. 1 plus 3 by 4 is 1 plus 1 by 4 is 5 by 4. Now U of 1 by 4 comma 1, last option. That is 1 by 2 into sine pi by 2 e power minus 4 pi square into 1, that is 4 pi square, that is 1 by 2 into e power minus 4 pi square. 1 by 2 into e power minus 4 pi square. This is also correct. So third option and fourth option both are correct. Next, del u by del t equal to a square into del square e by del x square. Del u by del t equal to a square into del square e by del x square. Initial condition u of x comma 0 is 50x by k, and the boundary conditions are u of 0 comma t equal to u of k comma t equal to 0. So here L equal to k. A square is a square. Now after applying the boundary conditions, the solution of heat equation is u of x comma t is sigma n equal to 1 to infinite bn sin n pi x by k e power minus n square pi square a square by k square t, called it 2. Now u of x comma 0 is sigma n equal to 1 to infinite bn sin n pi x by k, given that in the data it is given that u of x comma 0 is 50x by k, 50x by k from 3 and 4. We can write 50x by 4 equal to sigma n equal to 1 to infinite bn sin n pi x by k which is in the form of half range sine series. The value of Bn is 2 by k. L is k here. 0 to k 50x by k into sin n pi x by k dx. Sin n pi x by k dx. You have to apply integration by parts. Hundred by k square is outside. Now x and sin n pi x by k differentiation of x is 1, differentiation of 1 is 0. Integral sin n pi x by k is minus k by n pi cos n pi x by k. Now integral cos is sin n pi x by k. Here we have k by n pi, again k by n pi, minus k square by n square pi square. First term plus, next term minus, next term plus. Multiply diagonally like this. You will get 100 by k square of minus k by n pi x cos n pi x by k plus k square by n square pi square sin n pi x by k from 0 to k, that is 100 by k square of minus k square by n pi into cos n pi k by k na k cancel, cos n pi is minus 1 whole power n plus sin n pi is 0. Next term minus 0 cos 0, that is 0, and sin 0 is 0. Finally 100 by k square into minus 1 whole power n plus 1 by n pi. Now k square cancel, that is 100 by n pi into minus 1 whole power n plus 1. 100 by n pi into minus 1 whole power n plus 1. Now substituting the value of Bn in equation 2, we get u of x comma t is sigma n equal to 1 to infinite 100 by n pi into minus 1 whole power n plus 1 sin n pi x by k e power minus n square pi square a square by k square t. Understood? We have to calculate the complete solution. So we got 100 by n pi into minus 1 whole power n plus 1 into sin n pi x by k e power minus n square pi square a square by k square into t. Now we have to solve this initial value problem. We have to solve this initial value problem. Del u by del t equal to del square u by del x square. Zero less than x less than pi. U of 0 comma t is 0. U of pi comma t is 0. Observe, this is equation 1. These are boundary conditions. By applying the boundary conditions in the solution of heat equation, we get u of x comma t is sigma n equal to 1 to infinite bn sin n pi x by l e power minus n square pi square a square by l square t. In this problem, l value pi, a square value 1, l value pi, a square value 1. Therefore, u of x comma t is sigma n equal to 1 to infinite bn sin n pi x by pi is nx e power minus n square pi square by pi square cancel, a square value 1, n square t. Called it equation 2. Now u of x comma 0 is sigma n equal to 1 to infinite bn sin nx, called it 3. Given that u of x comma 0 is f of x, called it 4. From 3 and 4, f of x equal to sigma n equal to 1 to infinite bn sin nx, called it phi, which is in the form of half range sine series Fourier sine series, where Bn is given by 2 by L into 0 to L f of x sin nx dx. Okay. Therefore u of x comma t is sigma n equal to 1 to infinite bn sin nx e power minus n square t, e power minus n square t, where bn is 2 by L. L value is pi na, so here L is pi na, so 2 by pi 0 to pi f of x sin nx, where bn is 2 by pi 0 to pi f of x sin nx dx. That's why correct option is last option, e power minus n square t sin nx, where f of x is 2 by pi 0 to pi f of x sin nx dx. Understood? Next. Yeah, u of x comma t with the solution of initial value problem utt equal to uxx. U of x comma 0 is x, ut of x comma 0 is 1, then u of 2 comma 2 is. Yeah, we have to solve this problem by using D'Alembert solution of wave equation. Here the given differential equation is del square u by del t square equal to del square u by del x square, a square equal to 1. Now u of x comma 0 is x. Ut of x comma 0 is 1. This is f of x. This is g of x. Now u of, by D'Alembert solution of wave equation, u of x comma t is 1 by 2 of f of x minus at plus f of x plus at 1 by 2a integral x minus at to x plus at g of y dy u of x comma t is 1 by 2 of f of x minus t, so x minus t plus x plus t plus 1 by 2a, so 1 by 2 integral x minus t to x plus t 1 dt or 1 dy. Now observe, minus t plus t cancel, 1 by 2 of 2x plus integral y is y x minus t to x plus t. 1 by 2 into 2x is x. X plus t minus x plus t. Now plus x minus x cancel. X plus 1 by 2 of 2t is t. U of x comma t is x plus t. Now we have to calculate u of 2 comma 2. That is 4. Understood? U of 2 comma 2 is 4. Next problem. Let u of xy be the, actually u of x comma t be the, because it is one dimensional wave equation. So you have to calculate u of x comma t, where u of x comma 0 is given, ut of x comma 0 is given. You have to apply D'Alembert solution of wave equation. The given initial value problem is del square u by del t square equal to del square u by del x square. Now a square value 1. Now a square value 1. U of x comma 0 is 2x square. Ut of x comma 0 is 0. This is f of x. This is g of x. U of x comma t is 1 by 2 of f of x minus at plus f of x plus at plus 1 by 2a x minus at to x plus at g of y dy. A value 1. So f of x minus t is nothing but 2 into x minus t whole square. 2 into x plus t whole square plus 1 by 2 x minus t to x plus t. G of y is 0 dy. This integral is 0. This integral is, take 2 common and cancel with these 2. You will get x minus t whole square plus x plus t whole square. Now u of x comma t is x minus t whole square is x square plus t square minus 2xt, x square plus t square plus 2xt, minus 2xt plus 2xt cancel. That is nothing but 2 into x square plus t square. So u of x comma t is 2 into x square plus t square. First option. U of 1 comma 0 2 into 1 square plus 0 square, that is 2. U of take u of 0 comma 1. Zero square plus 1 square, that is 2. U of 1 by second option is correct. What about third option? U of 1 by 2 comma 0. One by 4 plus 0, that is 1 by 2. 1 by 2, that is correct. What about fourth option? U of 0 comma 1 by 2. Zero square plus 1 by 4, that is 1 by 2. So last option is correct. These three options are correct. B, C, D are correct. First option is incorrect. Next column. U of x comma t is u of x comma t be the solution of initial value problem. Del square e by del t square equal to 9 into del square e by del x square. A square value 9. Next, u of x comma 0 is x plus 5. Ut of x comma 0 is 0. Therefore, by D'Alembert solution of wave equation, 1 by 2 of f of x minus 80 plus f of x plus 80, 1 by 2a of x minus 80 to x plus 80, g of y dy, 1 by 2 of, here a square value 9, so a value 3, so a value 3, f of x minus 80 means x minus 3t plus 5, x plus 3t plus 5, this term anyhow 0, 2x minus 3t plus 3t cancel, 2x plus 10, that is x plus 5. Finally, u of x comma t is x plus 5. We have to calculate u of 2 comma 2. Two plus 5, that is 7. So final answer is 7. Understood? Right. Thank you.